Hello everyone. Today I want to share something that really changed how we work with Liquid Galaxy. Not just as an idea, but in a very practical hands-on ways. If you have ever used Liquid Galaxy, you already know how powerful it is. The 360-degree views, the immersion for the audience, it almost feels magical. But if you have been the person controlling it, you probably know behind the scene. It has not always felt that smooth. My name is RiteshVerma, and in this talk, I will show you uh, how we move from a slow manual control to setup that feels fast, responsive, and truly real time using API and WebSockets. And once you see this, you will understand why it makes such a big difference for the live demos, museum, and the interactive installation. So let's start with where we were, how Liquid Galaxy was traditionally controlled. Traditionally, controlling liquid galaxy rig is mean very close to the system, both physically and technically. If you want to do anything, the first step was usually logging into the master node using SSH. That already assume you know the system very well and you have credential and you are comfortable working on the command line. Once you are logging into the master node, the next step is to creating or editing the KML file. The KML file defines everything like camera movement, place mark, or overlays. So every changes start with opening a file and manually and editing it. Now imagine you just want to slightly move the camera or change the location or place mark. You still have to edit the KML file. After that, you can't just see the result. You have to copy that file from your local machine to the master node using SCP. So now we are already done three steps. SSH into the system and edit the file and copy it into the master node. And even after all that, the changes still isn't visible. To actually see the update on the screen, you need to reload the LZ or start the Google Earth on the rig. Only then you see whether your changes work or not. This entire flow is shown here on the slide, edit it locally, then copy to the master, and then the Google Earth reload on the screen. Now I want to be very clear about one thing. This workflow works. Liquid Galaxy has been used in museum, labs, exhibition for years using exactly this method. It's stable and reliable. And the issue is not whether it works. The issue is how it feels when you try to use it in live demo or interaction situation. Because here's what happened in practice. Every small change means repeating the whole process. You edit, copy, reload, and wait. If something doesn't look right, you do it again and again. This create a lot of latencies, not just network latency, but the human latency. You break your flow as a presenter or developer. You stop interacting and stop waiting. There is also authentication override. Every SSH and SCP step adds friction. It is secure, yes, but it's not lightweight. And most importantly, this step was never designed for the live interaction. Just imagine standing in the front of an audience. You want to smoothly move the camera or respond to a question or just jump to the different place. With this workflow, the moment is gone before the system reacts. So, while the visual on the Liquid Galaxy feel futuristic, immersive, but the control process behind it feel very old school. And this mismatch is the real problem. This execution flow becomes a bottleneck not because Liquid Galaxy is weak, but because the control method is slow and file based. And once you see this clearly, one question naturally comes up. What if we could control Liquid Galaxy without SSH, without copying files, and without restarting the Google Earth? That question is exactly what leads us to the Liquid Galaxy API. So in the last slide, we show the problem clearly. Liquid Galaxy itself is a powerful, but the way we are controlling it was slow, manual, and not built for the live interaction. Once you really feel that pain, the waiting, the repeating step, and the lack of flexibility, a very simple question comes up. What if we could control Liquid Galaxy the way we control the modern applications? The question is what lead to Liquid Galaxy API. So, what is the Liquid Galaxy API? At its core, it's a small Node.js service that runs directly on the master node of the Liquid Galaxy rig. This is important. Nothing moves away from the rig. The Liquid Galaxy setup stay exactly the same. The Google Earth stay the same, and the slave machine also stay the same. What changes is how we talk to the system. Instead of logging into the master node, instead of logging in using SSH and copying the file with SCP, the API expose control through the REST API and WebSockets. That means we can send simple requests like camera movement or KML update in a clean and structured way. You can think of API as a bridge. Once on the one side, you have modern user interface like a tablet app, a web dashboard, or even multiple device at the same time. On the other side, you have the Liquid Galaxy rig. The API sits in between and translate those high level commands into actions the rig already understands. And this is the key idea I want to highlight. The API does not change the Liquid Galaxy core system. If you look at the diagram on this slide, you will notice something important. The rig is on the right side is marked as unchanged. That is intentional. We are not replacing Liquid Galaxy. We are not rewriting its internal. Instead, we are replacing two very specific things: manual SSH command and a static file based KML workflow. Those red cross mark on the SSH and SCP on the slide represent exactly that. So instead of saying login, edit a file, or copy it and then reload the Google Earth, we just say send a command. And once we do that, a lot of new possibilities open up. For example, camera control becomes programmatic. You can move the camera using code, not by file. A KML is no longer something that you store and copy. It's become dynamic and injected directly into the system when needed. And because everything goes through the API, you are no longer limited to a single controller. Multiple devices can control at the same time through tablet, laptop, or a control panel, all talking to the same rig in a clean and consistent way. The most important part is this: the API modernized the Liquid Galaxy control without breaking anything. It keep what already works and replace what was slowing us down. So that we have a modern control layer, the next question becomes, how do we make the control feel truly real time? That's where WebSocket comes into the picture. So in the last slide, we introduced the Liquid Galaxy API and how it replaces slow manual workflow with a clean modern control layer. But just having an API is not enough. The next big question is, how fast does it fail when you use it? Because Liquid Galaxy is all about speed. Let's first talk about how many system traditionally handles updates. Most web application use something called Ajax and or polling. The idea is simple. The client keep asking the server, is there something new? And this happens again and again at the fixed interval. The problem is this create unnecessary network traffic. The server keep getting asked even when nothing has changed. And more importantly, the delay depends on polling interval. If you poll every second, the update can be almost 1 second late. If you poll faster, you increase the network load. Now, in a normal website, that might be fine. But with Liquid Galaxy, is not a normal website. That's where WebSocket come in the picture. WebSocket work very differently. Instead of repeatedly asking the server, the client open persistent connection where the connection stay opens. And now the server doesn't wait to be asked. It push update instantly the moment something's happen. And the two-way communication means a minimum latency and almost immediate response. And this difference is not just technical, it's something you feel. This is especially critical in 360-degree immersive setup like Liquid Galaxy. And when you are surrounded by a screen, your brain becomes very sensitive to the moment. Even a delay of around 100 milliseconds becomes noticeable. If the camera movement is stutter or start late or feels slightly off, the immersion break instantly. And once the immersion break, the experience feels fake. And the camera movement in the Liquid Galaxy must feel smooth, continuous, and natural, almost like you are physically moving through the space. WebSocket make that possible. They give Liquid Galaxy the real-time feel its demand. This is why in a Liquid Galaxy API, WebSocket are not optional. They are the core part of the design. They turn the control from something you wait for into something that feels immediate and alive. Now that we understand why real-time communication matters so much, the next step is look at the technology stack that make all of this work together smoothly. So now that we have talked about why real-time communication matters, the next question is how is this actually built? This slide shows the technology behind the Liquid Galaxy API, and I want to explain them in very simple way. At the heart of the API is a Node.js. Node.js is an event-driven runtime, which mean it's very good at handling lots of small, fast event like real-time commands, camera updates, or live data that make it natural fit for something like Liquid Galaxy, where responsiveness matters more than heavy computation. On the top of Node.js is Express.js for the REST API endpoints. It helps us clean, predictable endpoint like triggering a camera move or loading KML or checking the system states. It keeps the system organized and easy to understand. For the real-time communication, we use WebSocket. So here as WS, this is what enable that instant two-way communication we talked about in the previous slide. Now, no waiting, no polling, just immediate update. Now, an important question is why this stack. First, it's lightweight and fast, and we are not adding heavy framework or unnecessary layer. Second, it's easy to extend and debug. That's matter a lot in the real world installation where you want to quick understand what's happening if something goes wrong. And the third most important thing is real time system. This stack doesn't fight against the real time behavior, it's designed for it. And another key decision is where the API run. The API run directly on the master node of the Liquid Galaxy rig. That's very intentional. By running close to the Google Earth execution layer, we reduce the delay and avoid extra network hops. Commands don't travel far; they go straight from the API to the system that need to act on them. So when you put all of this together, you get an setup that is simple, fast, and responsive. This stack is not about being fancy, it's about being reliable, understandable, and real time. And now that we know that the API is built with, the next step is to look at how commands actually move from the system, from the user, all the way to the Liquid Galaxy screen. So now that we have looked at the technology behind the API, let's see how everything actually works together. This slide shows what happens when a command is sent step by step. Let's start at the top with the client layer. This can be a tablet application or a web-based control panel or any custom UI you want to build. From the client's point of view, it's very simple. The user click a button or just select an action. That action become a command. That command goes to the API layer, the Liquid Galaxy. The API receive the command through the REST or the web socket. If it check that a command makes sense, applies the logic and validate it. And this is important because no all the commands go from through one place. The API becomes the single source of truth for controlling the rig. Once the command is validated, it's moved to the execution layer. The master node execute the action, whether that's camera movement or a KML update or just a search. From there, the slave machine automatically sign with Liquid Galaxy's built-in protocols, so the entire rig stay perfectly in sync. The key idea here is consistency. No matter where the commands comes from, a tablet, web UI, or multiple devices, it always follow the same path. That's what make the system predictable, stable, and easy to extend. Now that we understand how commands flow through the system, we can move to uh, how this is set up improve everyday users starting with installation and integration. So now that we understand how commands follow through the system, the next question is very practical one. How do you actually start using this API? The good news is getting started is simple. Installation is done using the provided script. You don't have to manually set up things step by step. You run this script once and it install everything needed and start the API as the Node.js service on the master node. Once it's running, the API just stay there in the background and ready to receive commands. In term of access, the rest endpoint are exposed locally, so you can test and use them directly from the master node or from trusted client on the same network. At the same time, WebSocket server starts automatically such that there's no extra setup required. So the moment the API is running, real-time communication is already available. Another important part here is how the API fit into the existing Liquid Galaxy environment. Most of the Liquid Galaxy use OpenBox to manage full screen mode and the startup behavior. The API follow the same logic. It can trigger full screen script, use the same startup rules defined in the README, and work naturally in kiosk style environment. This means you don't have to redesign your setup to use the API. You install it, then start it, and it fits right in. And that easy of setup is important. The easy of setup is important because it let you focus on what really matters, building interactive experience instead of managing the system details. Now that we have seen how easy it is to get started, let's look at how this changed one of the most painful part of the old workflow working with KML. So now let's talk about one of the biggest changes this API brings. How we work with the KML. Traditionally, KML has always been treated like a file. If you look at the left side of the slide, this is the old approach. You create a KML, you copy it to the master node using SCP, and then reload the Google Earth to see the result. And every time you want to make a small change, you repeat the same step. This is not just slow, but it is also breaks your flow. Now look at the right side of the slide. With this API, you don't treat KML as a file anymore. We treat it as a data. Instead of creating a file, you send KML directly as a string. You push it through the API and visualization appears immediately. There's no file copying, no dependencies on the file system, and no need to reload or restart the rig. This makes iteration much faster. You can tweak something, send it again, and instantly see the change on the screen. And because KML is now dynamic, this is also enables something very powerful, that is live data visualization. You can generate KML on the fly from API, sensors, or external data sources and push it directly to the Liquid Galaxy. So KML is no longer a static asset that you manage carefully. It's become dynamic content that you control in real time. And once the KML become dynamic, the next natural step is to make camera movement just as flexible and predictable. So now that the KML is dynamic, the next step is controlling the camera in a clean, reliable way. This slide introduced the idea of abstract view control. Instead of moving the camera through the UI actions or a button click, we describe the camera using simple parameter. We define where the camera should be and how it should look and nothing more. These parameters are the things we already understand. Latitude, longitude, altitude, tilt and heading. All of these values are sent together in a single request. This is important because the camera movement becomes independent of the device or the UI. It doesn't matter if the command comes from the tablet or a web app or any automated script. The result is always the same. What does this matter is first it is just one JSON payload. Second, the camera behave in a predictable way every time. And third, becomes very easy to create a smooth animation by sending a sequence of these camera views. So instead of telling the camera how to move step by step, we simply tell it where to go. And that makes the camera movement consistent, declarative, and much easier to control. So once the camera control becomes clean and predictable, the next thing we can control is search. Normally in Google Earth, search is manual action. You type something into the search bar and press enter. With the API, search becomes programmatic. Query is just a text string, the same text string you would type into the Google Earth. For example, Golden Gate Bridge. API can send this query directly to the rig. So instead of someone manually type, the system trigger the search automatically and files to that place. This might sound a small, but it is actually very powerful because now you can build experience on the top of it. For example, voice control, automated storytelling, and educational demos. The key idea is here is simple. The search is no longer something a human has to be do by hand. It's become a controllable feature, just like camera movement. And this makes Liquid Galaxy much more interactive and much easier to integrate into the modern applications. So now that search and the camera control are programmatic, the next challenge is something very practical. What happens when more than one controller is connected? For example, a tablet, a laptop, and a web dashboard all controlling the same Liquid Galaxy rig without coordination. This can quickly cause problems. Different screen shows different states. Button doesn't match what's actually happening, and the camera might jump in unexpected way. This is where API state tracking becomes important. The API keeps track of things like the current camera position, which KML layer is active, and what the last command was. Because of this, the API always know the current state of the system. So when a new controller connect, it does not start with from zero. It immediately sign with the current state. The result is simple and powerful. New client are in sign right away. There are no sudden jump or anything else. Everyone sees the same thing. This makes a collaborative control possible, where multiple people can interact with the same rig smoothly and safely. And once everything stay inside, the Liquid Galaxy becomes much more relatable for live and public experiences. Imagine a museum where the guide is standing in the front of audience holding a tablet. The audience is not looking at the tablet. They're looking at the Liquid Galaxy rig. The guide tap on the location on the tablet and that single action send a command through a WebSocket. The API receive it and forward it instantly and the Liquid Galaxy rig respond right away. The camera start moving smoothly. There's no delay or any loading. The audience feels like they are traveling through the space and not watching a computer system. This means this works so well because WebSocket connection is always open and there's no reconnect time or no any waiting for the system to catch up. Everything feels continuous and natural. This is the moment where the Liquid Galaxy stop feels like a demo and start feeling live. And the kind of a smooth, responsive interaction is exactly what a public experience like a museum becomes engaging and memorable. So let me quickly bring everything together. We start with the problem. Liquid Galaxy was powerful, but controlling it was slow and manual, mostly based on the SSH and the file copy. What we did was move away from the model and introduce the real-time APIs. Instead of logging in and managing a file, we now send clean and structured command. This made camera movement smooth and low latency, which is critical for immersive 360-degree experience. By using REST API and WebSocket, Liquid Galaxy become much easier to connect with the modern user interface like tablet, web apps, and customized controller. At the same time, we are carefully not to break anything. The core Liquid Galaxy system stay exactly the same. The API simply sits on top and improve how we interact with it. All of this was designed with real use case in mind, like a museum, live demos, and public installation, where responsiveness and reliability and easy of use really matters. So, in short, we didn't change Liquid Galaxy is we changed how it feel to use it, make it faster and more interactive and ready for the modern real-time experience. Thank you for your time and attention. I hope this gave you a clear picture of how real-time APIs can make Liquid Galaxy more interactive and responsive.